In this video, we are going to take a look at two examples, one where we use Rolle's theorem to verify that there exists a number C that satisfies Rolle's theorem, and another that uses the mean value theorem. Let's first look at Rolle's theorem. So recall Rolle's theorem. It tells us if f is continuous on a closed interval from a to b and differentiable on the open interval from a to b, if additionally the function value at the two endpoints are equal, then we know that there is a number c in the open interval from a to b where the derivative is 0. All right, so let's look at our example here. Here we want to check that the conclusion of Rolle's theorem, check the hypothesis of Rolle's theorem and find a number c that makes the conclusion true. So let's first check the hypothesis. So the hypothesis of Rolle's theorem there are three pieces. So first, we need to have continuity. So our function needs to be continuous on the closed interval. We can observe that f of x equals x squared plus 1. It is continuous on -2 to 2. Since it is a polynomial. And polynomials are continuous everywhere. Item 2. The second thing we need to verify or observe is the differentiability. So f prime of x, the derivative, is 2x. That is our derivative. So our function, f, is differentiable on -2 to 2. Right? Polynomials are differentiable everywhere as well, so it is differentiable there. I wrote the closed interval. I actually don't need the closed interval. I just need the open interval from -2 to 2. There. And then the third thing that we need to have happen, the third portion, is we need to look at the function value at the two endpoints. And so our function value at -2, if we plug -2 in, we have -2 squared plus 1, which is 5. And if we plug in the other endpoint, 2, we also get 5. So our function values at the two endpoints, those are equal. So Rolle's theorem holds. And because it holds, we know that by Rolle's theorem, there exists some number c in the interval from -2 to 2. Right. So c is an element of the open interval from -2 to 2, such that f prime of c, the derivative at c, is equal to 0. And so this, our graph is actually a parabola. It's a parabola that's been shifted up 1. But it has 0, 0 as its center. We are going from -2 with a height of 5 to +2, also with that same height of 5. Great. And we are asked to find a number c that makes the conclusion true. So to find that, we are going to set our derivative. We're going to evaluate our derivative at c, and then set it equal to 0. So we have that point that's guaranteed is that point right at 0. And we can notice that the slope at that point is 0. That's what Rolle's theorem guaranteed us. Fantastic. So that's Rolle's theorem. The mean value theorem is similar, and that's what we're going to look at next. So we're going to do a problem similar to this last one, but we're going to check the hypothesis of the mean value theorem. So the first thing is our function, we need to observe its continuity. So f is continuous on 0 to pi/2 since sine x is continuous everywhere. And the second thing we need to observe is it's differentiable. So it's differentiable on 0 to pi/2 since f prime of x equals cosine x exists for all x in the interval from 0 to pi/2. Right? That derivative exists everywhere. Now, with the mean value theorem, it only needs to have those two pieces. We don't require equality at the two endpoints. We just require continuity on the closed interval and differentiability on the open interval. If we have those two things, then we can say, so the mean value theorem holds. So by the mean value theorem, there exists a c in the open interval from 0 to pi/2 such that the derivative at c is equal to the slope between the two endpoints. And so it's equal to f of pi/2, the function value of pi/2 minus the function value at 0 over pi/2 minus 0, right? So the change in the y values minus over the change in the x values. So this is 1 minus 0 over pi/2, which is 2 over pi. So we know, we are certain there exists some number c in this interval where the derivative at c is equal to 2 over pi. Now this asks us to also find that number c. So to find that number c, we are taking that derivative and evaluating it at c. So we have cosine of c. We are going to set the cosine of c equal to 2 over pi. If we were to solve that by taking the inverse cosine, we get a value of c that is approximately 0.88. So that is our value of c that we are looking for. We are also asked to illustrate it with a graph. So we have the sine graph from 0 to pi over 2. So at pi over 2, we're at a height of 1. At 0, we're at 0. So if we look at the line between there, we are guaranteed that somewhere right there, the slope at that point matches the slope between those two endpoints. And that's all we have. That is Rolle's theorem and the mean value theorem. In our next video, we will look at more information that the derivative gives us about graphs of functions. We will see you there.